Okay, guys, I'm going to do a few videos here based on your request. I did a request for number 15, and I could probably fit two videos. I thought I'd just do one right before that, maybe number 14. I don't know if anybody's requested this yet, but good to go over something. And we're dealing with a kite here, PQRS, and by the length of this thing shown, it looks like we can kind of assume that if this is the longer length here, 8, and this is the shorter length, 4, of that one diagonal, then you've got your two congruent segments there and your two congruent segments there. Okay, so we want to find the perimeter of the kite. If we just find one of each of those, we could just multiply by 2 and add them all together, right? So went around our nearest answer to the nearest hundredth as well, in case we need to. So let's look at what we're going to do. We know that in a kite, what's very helpful, especially in this problem, is that the diagonals are perpendicular to each other. They look like it here, and indeed they are. So what does that mean for my sides? Well, they also, one of them, the one that goes between the congruent angles, is also bisected, right? We know that these two triangles here are affected by that because they're this green line that I drew is bisected or bisects the blue line. The green line is not bisected, so you'll see 4 and 8 here. So if this is 4 up here. Okay. Now, what that means, if you look at that little triangle on the upper left-hand corner there, you've got 4, 4 for the sides. Those are the legs. Those happen to be congruent to each other, right? And you got a right angle, so that's an isosceles right triangle. Okay, so if we had to, we could find the length of the side by just using the fact that the hypotenuse is root 2 times the length of the leg, right? The hypotenuse is longer than the legs there. So you got 4 root 2 there. And we can round that to the nearest hundredth later in our calculator. Okay, then we've got another right triangle on the right. Let me just draw that to the right over here. 4 for one leg, 8 for another leg. And this other leg can just be found by Pythagorean theorem. Let me call it C. C squared has to be 4 squared plus 8 squared. Now, the mistake a lot of you guys make sometimes, the variable might be here, right? And you'd have to put your variable in there, but the hypotenuse is always the 1 squared. I always just like to write the hypotenuse squared, okay? If for some reason this doesn't look right to you when you're writing it down, that this side squared is equal to the sum of the other two sides squared, then maybe you did something wrong, right? Double check. And it looks like I have my two shorter sides and my hypotenuse, so this looks correct, okay? So C squared equals 16 plus 64, which is 80. So C, once we take the root of both sides, right? Oops. Square root of 16 plus 64, square root of 80. Okay. So that's square root of 80. The other one is 4 root 2. So we're basically going to take 4 root 2 times 2 and add it to 2 times root 80. I really don't need to, since we're asked to find it to the nearest hundredth, I can go ahead and plug this into my calculator. See what I get. 2 times 4 times square root of 2, close the parentheses. I'm just going to hit enter in my calculator, make sure that finishes because it looked weird. And then we're going to add that to 2 root 80. So add the answer to 2 times square root of 80. And I got about, for the perimeter, right, approximately to the nearest hundredth, 29.20 units. Okay. I'm going to go ahead and continue with number 15 here. I've got what is given to be a square ABCD. This is a square. So I know all these are right angles and all the sides are congruent. The diagonal BD is extended through D to E. Okay, so we got this diagonal drawn from B to D. That's the two vertices of the square. It continues and it goes out here. And CD is congruent to DE. CD is congruent to D. So that side of the square is also congruent to this side over here. Okay. And AE is drawn. Okay, we join AE. Now look, when we do that, notice what I've labeled here. If you just kind of take a look at this triangle, what kind of triangle is that, right? It's an isosceles triangle. If you started labeling the stuff as you read through the problem, you'd see that that is an isosceles triangle, right? So that may help us. Determine and state the measure of angle DAE. In fact, we're trying to look for that little angle in there, right? Well, it's an isosceles triangle, so that little angle in there, the base angles have to be congruent. So you know angle E is congruent to angle A because it's an isosceles triangle, right? But that little angle E there is also in this big triangle, which we can figure out something because we have the diagonal cutting through here, and we know the diagonal of a square is like the diagonal of a rhombus. It bisects the angles. So that means each of these little triangles is 45, 45. So this angle is 45, right? So I'm looking at this triangle right here. I've got a 45-degree angle there. I've got a 90, which is part of this whole thing. And then these are my two variables that I really don't know, but they're the same. So what's great about that is I can just call each of them some variable like n, right? So if I'm looking at this triangle, let me highlight it in pink. Look at that triangle. I've got a 45-degree angle as one angle. I got a 90 plus an n as one angle, and n is another angle. So that means I got one variable, which would enable me to write the equation 45 plus 90 plus n plus another n is equal to 180. Okay? Combine some like terms. Throw this junk on the other side, right? I got this junk. This junk is 135. Got my junk in my trunk. I'm going to put it on the other side because I don't like the junk in my trunk. I'm going to go work out. I'm going to do some workouts, man. I got too much junk in my trunk. My trunk was 180. My trunk was 135. Let's bring it over the other side. So now I got what? I got 2n on the left, and my junk in my trunk got subtracted, which is nice. Got it out of there. So it's almost 50. It's 5 short of 50. It's 45. And then we're going to divide by 2 on both sides, and we get n is 22 and a half. Okay? You can leave it as 45 halves. You can make it into a decimal. It doesn't say how to leave our answers here, but we're supposed to leave them as an exact answer. So 45 halves or 22 and a half or 22 and 50 cent. If you want to speak in rapper terms, I got 22 and 50 cent over here. You got a 22 caliber and you got 50 cent. So in your mind, you're picturing that picture of 50 cent with the 22 caliber. Okay, that's the answer. Peace out.